Okay, so this will be a nice break from, we've only got 5 minutes left, one of the shortest videos ever. You guys will like this, okay? If I told you to solve 2x plus y equals 1 and 3x plus 4y equals 14, two equations, two unknowns, two ways to solve. So, how about Daniel? It must be your turn. How would you solve that?
Dude, I'm so fried right now, I don't know.
What is it, Jim?
Eric, on the top one, subtract 2x to the other side.
No. Oh, I see what you're doing. You're doing substitution.
Yes.
Okay. So substitution is one way. Now, the nice thing about substitution is you can get a y equals, just as Eric said, if you subtract the 2x. So I'm going to get y equals 2x plus, y equals 1 minus 2x, right? If you subtract the 2x from both sides. Everybody see that? Okay, and then what?
And then you insert it to the y.
I'm going to insert that into the second equation. So this becomes 3x plus 4 times 1 minus 2x equals 14. So we'll distribute the 4. 3x plus 4 minus 8x equals 14. Then what?
Subtract 4 to the other side.
Subtract the 4. So that goes away. 3x minus 8x, negative 5x equals 14 minus 4. 10 divided by negative 5. X equals negative 2. So that's one answer. How do we find the other one? Plug it right into there, right?
Yeah.
So y equals 1 minus 2 times negative 2. 2 times negative 2 times negative 2 is? 4. So 1 plus 4? 5. Y equals 5. Okay? So that's substitution. Nice and easy. Okay? A lot better than logarithms. Okay? Told you the logarithms would be the bane of your existence. All right, so the other method that I'd like to teach you really quickly today, we're not going to be able to cover this whole section, but we'll just do the easy stuff. How's that? Is elimination. Okay, now substitution, sometimes substitution's easier, sometimes elimination's easier. I will say that elimination is probably what we're going to focus on more in this chapter, but we'll do a nice little easy method here. How about 3x minus plus 2y equals 14 and x minus 2y equals 2. Okay? All right, so now, Landon, can you help me do elimination on this one?
Yes, sir. With both equations, the 2y.
Yeah, we can eliminate the y's, right? 2y minus y is 0. So 3x plus x.
3x plus x is 4x.
4x equals.
We're adding them together, so that's
16.
Divided by 4.
Divided by 4. X equals 4. Okay, I've got one answer. How do I get the other one?
Plug it right back in.
Into which one?
Do the bottom one.
The bottom one?
Yeah.
Does it matter?
No.
No, doesn't matter. So we'll do the bottom one. So you got 4 minus 2y equals 2.
Then you're going to put the 4 on the other side.
Subtract 4. Negative 2y equals
Negative 2.
negative 2.
By negative 2.
Negative 2. Y equals 1. Okay? And theoretically, you should check your answers. Now, the one thing, since we've only got a minute left, the idea here is we've got two lines. This one sucks. I don't know what they look like, but the idea here is, let's say one line looks like this, one line looks like this. If I were to graph each of those, I could, and the idea here is, according to this, if these were the two lines graphed accurately, that would be 4, and that would be 1. That's where they would intersect. Okay? So, as far as homework, the nice thing is, I think, actually, let me do one more really quick thing. Yeah, then we'll be done with this section. Wow, that was amazing. This is the easy section. What if I was going along here and I would have gotten something that like, so let's say I add these together and I got something like 0 equals 29. What would you say? You'd say I didn't owe you any more money, right? Okay. You guys are terrible. That joke just went. Okay, this is an impossible statement, right? Okay, so there would be no solution. In this kind of a situation, probably what's going on is you've got two parallel lines. They never actually intersect. And so if you get a false statement here like this, there's no solution. I think the book also calls it inconsistent. Yeah, inconsistent. Inconsistent. Actually, let me show you one more. What if I got something that said 3 equals 3?
It's all real numbers.
Well, all real numbers, not necessarily. Now, here's what I would tell you. If you get something like this, the back of the book is going to have something different than what I'm going to tell you. Because it's all real numbers that satisfy the equation, and they give you a weird thing. Here's what I would say. This is what we would call a dependent system. Okay? And in the back of the book, I don't think they call it dependent. The idea here is what would happen is you would have the same line twice. Okay? The lines are on top of each other. So you would have an infinite number of solutions, but you couldn't just pick any number. It would have to be any number that follows either one of those equations. Okay? All right, this is a nice, easy section. You'll like it. Quiz tomorrow, 5.1. See you all tomorrow. We'll do oh, by the way, one more thing. I'm going to try very hard to get the review up. If it's not up within 2.5 hours, text me, and I'll put it up, okay? See you all tomorrow.
What?